So we've really kind of walked through the fundamentals of like creating a Git repository and making some commits and merging and branches. So Git is the program, right? I wish there was a way to get rid of that. Anyway, Git is the program that we use, and we can use it for version control. Before Git, there was other version control software. It's still around. I think Google uses something called Mercurial, though they also sort of do their own thing. There is something called SVN. There's also something called Maven, I think. This is exactly what I want if it doesn't get too blurry. Is this too blurry to read? I realize this is super blurry. Yeah, this is maybe a better one. So this is still a little blurry, but this is a bit better. This is how version control used to work and still in many ways does. You've got your central server. In fact, you can think of this as the origin, which is, as many of you know, a Git term. The remote origin. Local is our own computer, remote is somewhere else over the internet. And we've got this central server, and we've got the people on our software development team, all 20 something of us doing work without worrying about the branches or anything like that, because this is just about moving stuff back and forth. We can all have copies of version control, and then we send it up to the central server. So most version control software before Git only worked this way. You had to organize stuff this way. On a practical level, this is probably at least 50% of how Git and GitHub are used. Certainly in this class we do. Everywhere I've worked, it's effectively been like this, where the GitHub repo is our central server, and we all work off of that. You don't necessarily have to with Git. Git was explicitly designed for like more distributed version control. And let's see if I can find like a good diagram. Yeah, none of these are really, I feel like, capturing what I want to illustrate here. And that's okay. This one is not bad. Let's see if this one does us any good. And after this, I'll dive right into kind of GitHub and stuff, but just to kind of paint a picture. So I apologize that this is a bit blurry, but hopefully this captures the idea. And where it says origin in the center, think GitHub. And remember, GitHub is essentially a server in the cloud, right? It's like a whole bunch of virtual servers, really, but for our purposes, it is a server in the cloud. Git was designed from the get-go by Linus Torvalds. He sort of wrote Git to help his like worldwide team of volunteers that were building the open source Linux operating system manage version control for Linux. That's why this thing was built. So this is like a flat team. People need to share stuff with each other. He didn't want a big central server. I don't know all the reasoning that went behind it, but unlike this, where the only thing you can do is send it to the central server and then everyone has to talk to the central server, you can have side channels here. We have this origin, but if Alice and Bob are collaborating, they can send stuff to each other with pushing and pulling with Git. It is on a practical level, like everywhere I've worked, it was never used this way, but that is part of how Git was designed. So I just want to very kind of briefly touch on this and give that little bit of a history lesson of like the history of version control. And really, in a lot of ways, GitHub, for many, if not most people using Git, sort of has filled the role of origin here. And again, on a practical level, Git with GitHub is usually used like this. But in theory, we can, with Git, send stuff to wherever we want. And actually, it is used that way, like for deploying code into production servers. It's actually used all the time for that. I take that back, because I've worked at places where we have a server in the cloud that's hosting our website. And the way I sent my code there was by using Git. So I'm going to dive into the sort of practical hands-on lesson soon, but I want to see if folks have any questions or are curious about anything before I do so. Cool. So that is the program Git, and that's what it was designed to do. GitHub is a company. Microsoft acquired it, but it wasn't originally owned by Microsoft. And it was designed to be the centralized server, the hub for GitHub, and sort of a social network for programmers, a place for you to back up your local Git repo on the internet, to send it to a remote computer. As you can tell, GitHub also gives you a really nice user interface for looking at code. And I showed this to the WSL folks yesterday, but let's just like very briefly look at a real project, React.js on GitHub, and kind of see how it's used. And I'll talk about a pull request in a minute, but the essence here is that this is how you merge stuff. Like, this is how you get review from other people before you merge something. And I have no idea what this is, but you can see people create issues, people have discussions, people do links to lines of code. There's a whole system for how branches are named, and this GH-267 blah 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 blah, and the name of this branch corresponds to whatever this bug is. So someone reported a bug, a radio button isn't doing what it's supposed to. Someone on the team got assigned it. They created a branch with that name according to the team's branch naming rules. And this is all stuff like we will just barely scratch the surface of this in the group project. This is all really more your first job. But again, I just want to share a little context, and then we'll dive into the tutorial. Though I realize actually we're approaching noon, so we should dive in sooner rather than later. I apologize about that. And you can see a lot of comments that people make. We've talked about commits. Like, if I'm reviewing this person's code, this is the value of commits and commits messages. As a member of this team, I can look at this. I can say, can you explain what is happening here? I think I get it, but I'm not certain. So code reviews are used for learning as much as anything. And we can see the files changed. So all of this is GitHub, right? GitHub is using Git, like that's under the hood. Commits, commit messages, but this user interface, pull requests, all of this stuff, that's GitHub. And that's what I wanted to illustrate. So I want to kind of check in to see what questions people have about that. Everyone feeling okay? Cool. Okay, so let's carry on. And I apologize because we may not get as far as I wanted to, because I did go down a little bit of a rabbit hole here, but we will definitely grab an assignment from our assignment repo and clone it and set it up for us and make a commit or two. So GitHub has organizations. So like a company will have like one organization. We're eventually, Code Platoon is going to centralize. For historical reasons, we're a bit spread out. Let's pick a problem that we haven't seen yet. And let's pick one that's in Python. just so we can do something with it. I'll go 99 bottles. Pi, perfect. So I'm going to throw this link in Zoom, and in a moment, we're all going to clone this. So please do open this up in your browser. I can share the command, but so as many of you probably know, the way to clone this is you click under code, and you have to make sure that you've got the right authentication setup for how you've set up your GitHub, which is what we went through yesterday. WSL folks, most of us are SSH. Mac folks, it's however Francisco walked you through setting it up, and you hit copy to paste it. And now in VS Code, so VS Code, it can be a little confusing living in the terminal to know where you are. So I think to make life simpler, I'm just going to go open projects. And now I actually have two VS Code windows open. Oh no, it's just the one, which is great. So that's what I want. Because this way, my editor's here, I know where it is. The terminal is where I think it is. I'm going to do pwd just for a sanity check. And now I'm going to do git clone and that URL. So please go ahead and do this now. And so now in our projects directory, we should have this directory. I'll go 99 bottles py, and please navigate into there. And remember to get in the habit of using tab on the command line. And if we do ls, we see the files in the project that we got from GitHub. If we do ls-a, we see the .git, the Git directory that was created for us when we cloned this Git repo from GitHub. So we don't have to run git init. If I do git status, I'm on the main branch. If I do git log, well, we only have one commit in here because I think we just pulled the whole thing in. But if there were more commits and stuff, we would have the whole history of our project here. I'm curious if we have, so we have a solution branch. Don't look at it till you've worked on the problem, but I can grab that too. If I do git branch, let's see what we have. If I do git fetch, which we have not talked too much about, but that will get me a list of all branches. It actually did not. I lied. I apologize about that. Well, if I do git checkout solution, then it will. So and now I've got the two branches, but we want to stay on main. Don't worry about the solution branch. We are going to live on main. So that was step one. Step two is, and everyone I think saw this yesterday, is changing the git remote, because we want to point to our own GitHub. And the reason for that is a couple reasons. So there is a way to copy this onto your own GitHub account called a fork. There are a couple reasons why we don't do that. One is if we ever got rid of this repo, say because we renamed it, everything that forked from it kind of goes away. And we want you to be able to have your work. That's really the big reason, to be honest. The other reason is this is good command line practice. It's as in like doing drills and repetitions and getting used to stuff. So I need to create a Git repo on my Git account, and then I need to point this one that I've cloned to it. And if I run git remote -v, this tells me what Git repo up in the cloud, what remote this one is connected to, what the origin is. Remember, origin, central server. Right now, the origin is the repo in the code Platoon GitHub org. We want to make this point to our own GitHub repo on our own GitHub account, so we can have our own code that we'll write for our portfolio on our account and to use as a reference until the end of time. So go to your GitHub account. If you just type github.com, that'll do it. There are a bunch of ways to get there, but you want to get to your GitHub homepage. and then create a new repository. For owner, make sure it is you. You may belong to some Platoon GitHub orgs. And let's add the name of this, and I'm just going to make it be the same as the other one for simplicity. And I guess I must have done this already. So you guys don't have to add the 2 at the end. I'm adding the 2 at the end because I think I did this yesterday with the WSL folks. Don't add a template. Add whatever description you want. There's no harm in making it public. If you want people to see the code you write. If you want to make it private for now, that's also okay. I suspect employers mainly look at their portfolio project, but having problems that you work on can't hurt. Some students, I think, like make one big repo and put all their assignments in it. Like as you get comfortable with stuff, if you want to do that, you can. For now, we want to make sure that you get a lot of practice with Git and GitHub, and this forces that. So skip all this stuff with the README and everything, because we're going to get it from the repo that we cloned. Just go ahead and hit create repository. And let me pause and see if folks have any questions, actually, because I haven't done that in a minute. Okay.
What did you say the git remote -v does again?
Excuse me, I was just drinking a little coffee. I forget what V stands for. If we do git remote -- help. So this git remote command, sort of, as you guys are starting to see, the command line commands all sort of stack on each other. Like one command has an argument that then has other arguments. So this git program has an argument remote that then has its own commands. And it's all for managing where tracked repositories. Think other repositories on other computers that our Git repo is connected to go back to this diagram. Like, we are not going to do this, but if I'm Bob, I could have multiple remotes, origin, and maybe I name one Alice because I'm collaborating with Alice. So I can maybe have a whole bunch of these to manage, but normally you really just have the one. And the -v, you'll see this in a lot of command line commands. It stands for verbose, which kind of means just like give us information about stuff. So we are saying Git, tell me the other Git repos that we are like set up to talk to. And Git says, cool. Well, there's just really this one. The name for it is origin. The URL is this. And this is the URL you use to get stuff, to fetch or pull. And this is the URL you use to send stuff to push. And it's the same. It's usually the same. It doesn't necessarily have to be the same. Does that make sense? Cool. That is a great question. And we're going to change this remote URL to point to the repo that we just made. So I'm going to copy this URL link. And again, make sure that you've got this set to the way that you're doing your GitHub authentication. So it should look the same, right? Like I can tell that I'm using SSH because it starts with Git at GitHub. If this URL is looking different, then I'm doing something wrong. And we're going to set this remote. And this step is slightly different from what's in the guide because the tutorial, I will just show you guys. So there's, I'm pretty sure there's a minor difference here. So we have this. So this is this tutorial walks through creating a new repo on GitHub right off the bat, and I did it slightly differently, right? Because we are going to be cloned an existing repo and we're now going to point it to the other one that we created. So we're not adding an origin, we need to change that. And I'm just going to very quickly do a Google search. Git remote change origin. And in fact, I searched this yesterday. And lo and behold, this looks exactly like what I want. And let me walk us through this command. Git remote, and let me make sure I have the set URL right with the dash. Set URL. So this is our command set, right? The Git program using this remote command, which then has this other command, set URL, and now we're actually going to enter in the data. The name origin, like we can assign whatever name we want but by convention, it's origin. So that's the name for this that we sort of use to refer to stuff and Git uses for a bit. And then the important part is the URL, because that's actually what Git uses to talk to stuff. And that's what I have copied from this repo that I made on my GitHub account. So this local repo that we cloned from the code Platoon assignments org, we're changing the remote URL to point to our account. And now if I do git remote -v, it should point, this should be my URL. Now, if I do git push, this is the moment of truth. It should push. It says to GitHub/AdamC, my GitHub account, which is great. New branch, because that GitHub repo that I made was empty. It had nothing. I got no errors. If I go to my GitHub and this repo and refresh it, I have my stuff. So I'll pause here to give everyone a sec to catch up. And while I'm doing that, do folks have any questions or things that you would like me to step through again or that you're curious about?
So when you cloned, it was pointing to the code platoon's origin.
Correct.
Okay.
Exactly. When you clone, the remote is going to point to wherever you clone it from. Great question.
I got it rejected when I tried to git push.
When you did the git push.
Yeah.
Double check the URL and that you have the name of the repo you created. I would double check like the URL and that the names look right. Otherwise remind me and let me come back to that and dig in. But if it's rejected, I would also double check that you created the repo. But double check the URL and the repo and Josh, remind me, and then we'll circle back at the end of class. And actually, let me make a note of that right now. And thank you for being understanding, because I just want to make sure that we have enough time to dig into stuff. Though, yeah, and did this work correctly for most folks? And actually, the sanity check is always good because every now and then there's some step that I forget. So then it's like working for me, but no one else. Andrew, yes, sir.
Yes, I just got a little bit behind there because I had an error that I had to figure out. So after git remote set URL, you type in git push. Is that correct?
Correct.
Okay. And what should that result in?
That should look something like this. It'll say stuff, but basically nothing bad. And you should see to the new URL. And there shouldn't be anything that looks like an error.
Okay.
And then you should be able to go to that repo on your GitHub account and see all that stuff there. And note that I've got the commit from Francisco. I've got the history, which is cool. And in fact, well, I think I only have the one branch. So I only pushed the one branch, of course.
Okay, I'm getting an error at saying rejected.
Okay, so you're getting rejected as well.
Yep. So I wonder if that has to do with how I authorized the, whether it was HTTPS or what's the other one?
Yeah, it very well may be HTTPS versus SSH.
Yeah.
Um, are other people getting rejected? Okay. Okay, cool. Then I just wanted to make sure there wasn't some step I missed that was totally throwing everyone off. So the easiest thing probably to do is for the repo on your account that you created. If you click under code, this clone URL, that's their URL that we're changing the remote to, and there's these 3 different options. So this is how you can grab the right URL that you need. In terms of making sure you're using the right one, Andrew and Josh, you were both able to clone successfully, right?
Correct.
Yeah, I would try. It is if I had to guess, you may have used a different kind than you used to clone. But let's remind me, and I'll check in with you guys after class. And folks, I apologize. Realistically, I'm probably gonna have to run just 10 minutes long. But we're almost home because now we're into more familiar territory. So I'm just gonna thank you all in advance, and Josh and Andrew, I'll connect with you guys and debug once we wrap up. So I just, especially as we're towards the end of class, I don't want to make stuff too complicated. So I think we're just going to do like a commit or 2 and a branch and a pull request. And we kind of saw this before. And let's open up, let's just create a new file, actually. So let's just do touch foo.py and foo. My computer science teacher used these terms foo and bar. I actually got really curious, and there's a couple websites about like programmer history, and I think they came, like, computer science kind of has like a couple cultural sources of origin, and one source is basically like MIT and Berkeley, and Stanford, and I think it came from like the MIT computer science people in the early days, but because this was like post World War II, a bunch of those people served in the military, so that is really this, which most of you, I think, are familiar with. So anyway, that's like example stuff. And let's just do code foo.py now that we've created the file. And let's just print, something like, let's just print bar or hello world or whatever we want to print. And now if I type git status, we have an untracked file. We know what to do. Git add dot, git commit -m, and just how about created foo.py. Git status tells me my working branch is clean. My branch is ahead of the remote one by 1 commit. And Clarice, you were asking about like when to push, and I would say just push after every commit, unless like until you get to the group projects. This is basically what you can do. Like when it's just you on a branch, you can just push up to GitHub all the time. So to set the stage before we push, our commit history is just this one branch here, right? Here, our commit history on the main branch is 2 because we've done this other one. I now do git push. Now that commit is sent up to GitHub. Now it's up there. And now not only do I have it saved in case I lose my laptop or need to work on a different laptop, but if someone else wants to get my work, they can pull from this as well to get the work, right? To go back to these diagrams if someone else wants, this is how we can share code. So I'll just pause here for folks to catch up and also to see what questions people have, or if there are steps people would like me to go through again. Cool. So we're almost done. I think we'll be able to wrap up pretty quickly. The last piece I want to do is we're going to create another branch. We're going to make a change. We're going to push that new branch up, and we're going to do a pull request. And I'll talk a little bit about what a pull request is. So let's check out a new branch. Let's call it my feature. Of course, I'm going to do git status to make sure everything is as I think it is, and I haven't lost my mind. And the feature is going to be really simple. Instead of printing bar, I'm going to print hello world. And you can make whatever change you want here. The important thing is I do want you to change what's in the print statement, because I want us to see what it looks like in a pull request when a line has been changed between branches. So as long as the print statement says something different, you put in whatever you want. Git status, I'm on my feature branch. Something has changed. Git diff reminds me, oh, I changed the print statement. So let's add it. Let's commit with a message. Let's just say change print statement, or whatever we want to say here. And let's actually say change print statements on my feature branch. So we can, when we're looking at this in a bit, we can see which commit message is from what branch. I want to wait a minute for everyone to get caught up. And while I'm doing that, do folks have any questions or things you'd like me to go over again? Cool. So this is the good part. Git push, however, message. So two things here. Big picture, the lesson here is always read the error message. Because especially new to computing, very understandably, this is a very dense error message, and it can be kind of intimidating. And the reality is, I do not know this because I read the error messages. It's because everyone kind of learns through, like, you get your fingers burnt and then you learn what it is. But there's a lot of error messages actually, and actually when I'm programming, by far, like when I kind of do my little retrospectives, like if I've spent an hour debugging and I'm like, what could I have done better to be a little more productive and efficient? Half the time, the answer is if I had thought a little bit more about the error message or read it a little bit more carefully, I would have gotten to the solution quicker. And Git, actually, this is a good error message as error messages go. Now, there's a little bit to understand. The current branch, my feature, that part we get. Fatal sounds scary, but it's just a fatal error is something did not work. Has no upstream branch. So upstream, downstream, source, origin, the source of the waterfall. Our origin is GitHub. This repo, the Git repo on our GitHub account does not have that branch. My feature, it does not exist. That's all that this is telling us. And that's what it means by upstream branch. And then Git even tells us how to solve this. And by the way, this happens every time you create a new branch. This is just a normal part of the workflow. I'm just kind of walking through it to walk through some terminology and also practice how to read error messages. And the great thing is Git tells us what to do here. To push the current branch and set the remote as upstream, use git push set upstream origin my feature. And I will admit, I have a hard time parsing exactly what set the remote as upstream means, but I get the essence of this. We need to create the branch on the Git in the cloud on GitHub. And that's what this command does. git push dash dash set upstream origin my feature. So this does two things. It creates this branch my feature on the Git repo on our GitHub account in the cloud, and it pushes up the commit that we have on our local machine up there. And it does both things. And you'll see this every time you create a new branch, and it's just part of the normal workflow. And we get a bit more in our message here, right? Compressing, writing, remote. If we want to create a pull request, it actually gives us a URL to do it. I'll just show you how to do it through the UI, which is how I normally do it. And now this branch, my feature on my local repo is connected to the one on origin. So Git will do a little bit of checking in when I'm doing work on this branch to see what's the state of this branch on the other one. And now if I go here, lo and behold, GitHub's beautiful interface has even popped this up, which is what we'll do in a sec. But if you go here, well, let me actually refresh the page. And now we see the My Feature branch, right? And in fact, I can click on the My Feature branch and I can even look at the commits. Here's that commit. You know, I can see that specific commit. GitHub gives us a nice visual difference. If I switch back to the main branch, there's only 2 commits because that commit is not on the main branch yet. Any questions or things that people would like me to go over again? Cool. So GitHub very nicely gives us this compare and pull request button. We can also do it another way, which I'm going to show now. So click along with me, and once we make the pull request, I'll explain what a pull request is. So just normally we just click on this, but just so we know how it works, just click on pull requests. Just go ahead, click on new pull request. So a pull request does not merge anything or change anything in Git. A pull request is like me asking someone else for a review. It's like me saying, I am ready for this work to be reviewed. So creating a pull request is always safe. And that's a common question that people have. You can create pull requests all day. It won't merge anything. It won't cause conflicts. It won't overwrite anything. A pull request is a request for people to review my code. And then when we get the thumbs up, we merge, right? We've talked about pushing and pulling. So the metaphor is a little confused, but imagine pulling my feature onto the main branch, which we call the base. When we do a merge, we talk about the base branch and then the other branch. So base is main, the compare over here, we merge. And again, to be honest, like GitHub gives you the button to do that automatically, and that's the easier way to do it, but I wanted to walk through this flow for everyone to see it. So please go ahead and do this. Your base is main, your compare is my feature, and hit create pull request. And note that it grabbed my commit message and put it here. And we can add something here. The Markdown editor is amazing, by the way. You can add like code in here. You can add checkboxes. GitHub Markdown is great. And that's why like people do so much stuff with it and why we do as well. And you hit create pull request, which is always safe. And let me pause and check in and see if people have any questions or things they're curious about, or if anyone ran into any issues. Cool. So now if we were working on a team, I could choose someone else and say, hey, I want you to review my code. You know, when it's just me, that like it's kind of like practicing an instrument or practicing a sport by yourself. But we get a lot of great information here. Checks, we don't have to worry about. I think that's something related to testing, or I think it's related to like adding check marks. So there's like a whole standard practice around check marks. Commits, we've talked about. We know, right? Because there's only one commit we made on my feature branch. files changed. This is where you do most of the code review. This is where, someone might say, actually, we want this to be hello world. Please make change and then resubmit PR. Right. If I was like a senior dev mentoring a junior dev, I might do that and like hit start review and then pretending the junior have it would be like done. And I get like a message and then I would review it again and say, great job, looks good to me. Which is one of these phrases that gets used all the time. So there's all sorts of fun stuff you can do there. Finish the review. I can't approve myself, I guess. So I won't worry about that. So down here, merge pull request. That does the exact same thing of if I'm on the main branch and I do git merge my feature, I'm not going to hit enter, so don't actually do this, but you all remember us doing this a little earlier. This is exactly what that pull request is going to do. Right? Merge one commit into main from my feature. It's exactly what this does. Does everyone feel good about that? And do folks have any questions? Cool. So the amazing thing about pull requests, and honestly, if you want to like impress a potential employer, as unexciting as it sounds, really descriptive commit messages and pull requests on your public GitHub repos are the way to go. Because as you guys saw with GitHub, a shockingly huge amount of being a software engineer is about documenting stuff and dealing with like all these things, and you'd be shocked how much of it is about stuff like this. And this is honestly, this is the stuff that you don't really learn in the course. Like we kind of teach you the core technical skills, and a lot of these practices are kind of like the next level. But like if you want to make, when you get to personal projects, if you want to make your personal project stand out, good documentation, tests, like pull requests, caching, which is another thing. But as you can see, like this pull request message is really descriptive. And if I look at the commits here, so these ones are a bit less descriptive. But the reason for this is on a big code base, I might be given a feature and then I might have to search through the pull request history to figure stuff out, like, which is, I'm not going to lie, a little bit of a double-edged sword. Like, let's see if there's something here that's not a bug, though it all seems to be bugs. But point being, like the pull requests and commit and messages and that history like really function as documentation. And that's why people get kind of obsessive about it. So we can go ahead and hit merge. If we wanted to change our commit message here, we could, but we don't need to. Pull request successfully merged. If you want, you can delete the branch. Otherwise, you can leave it. And now if we go back to the repo on the main branch, we have, in fact, 4 commits. The one with the change and what's called a merge commit. And I always get a little fuzzy here. It's a little bit of duplicate. This merge commit is really for documentation purposes. There's one more step we have to do, and then we're done. So thank you all for sticking around. Before I do the final step, do folks have any questions? Okay, this last step is really easy. And again, thank you all for running 15 minutes long. I will do my best in the future to make sure that we stay within time for lunch. This last step is really easy, but also extremely important. So I want to make sure that, especially because I know it's time for lunch, we're all paying attention. So we have merged our pull request. The main branch on our remote Git repo in the cloud on GitHub now has all that work. What about on my computer? On the local branch? On main, do I have that merged code from the other feature branch here? No, I do not. Now, I could do this because I know it's exactly the same, but we do not want to do this. Because most of the time, the whole reason of making a pull request is for review and changes. And this is really happening in a team environment. So other people may have added other stuff from other feature branches onto main. So start thinking about, what is my source of truth? GitHub is my source of truth. Also, that avoids conflicts where if like, because Git has all these different ways of kind of combining things. So it is easy to create conflicts if I did it in a different way. Like if nothing else, that sort of documentary merge commit could confuse stuff. So in fact, here, git status says it's up to date. Git fetch, which just kind of gets information about stuff. So the git fetch command we haven't talked a lot about. If I run help, this does not sound super descriptive. Downloads, objects, and refs. Short answer is git fetch checks with GitHub if other people have pushed stuff to the branch. Because now when I run git status, your branch is behind origin main by 2 commits and can be fast forwarded. Use git pull to update your local branch. When I ran git status before, it did not say that. Because it did not know. Git fetch is like ET phone home. Now, I could have done git pull without git fetch because I merged the PR. I knew it was there. I just wanted to demonstrate to you guys what git fetch is. So the git fetch is optional. The important thing is on main, we get the source of truth from our remote repo on GitHub, git log, merge pull request, change print statement, good to go. Hello world instead of Baz, and all is well with the world. Your branch is up to date with origin main. If I do git push, nothing happens. It just says everything is up to date. So I apologize for running a bit long. Thank you all so much for sticking around. And we have now finished the flow of how to grab an assignment repo, set it up so we've got it connected to our own GitHub, and then make some changes. And we've even seen how to make a feature branch and do a PR, which you all will not have to do for most of your daily assignments, at least right now, though we try to do as much as we can. So thank you all very much. Again, I really appreciate you all sticking around a bit longer. We're going to break for lunch. I think what I will do is very briefly talk about the assignments for this afternoon. And I'm sure, I don't think we have anything administrative on the calendar. I think it's just work. And we have not assigned, like, we're going to do pair programming on Tuesdays and Thursdays, but I think we kick that off next week. So today is really practicing this. So today's really our first work day in the afternoon. WSL folks, I do want to grab you all to get you set up with Postgres. Josh and I apologize, I didn't get the other person's name down, but anyone who had technical issues that you want to go over that came up during the lecture, I want to connect with you guys. But really the task for today is this stuff here under today's lesson, the Git practice, learn Git branching. This one is the same. So let me do a very brief walkthrough of this before we break for lunch. And basically take an hour for lunch, come back. If you all want to work together or in groups, you absolutely can, but we're not going to assign stuff today. So this Git practice repo is an assignment. A lot of this should be familiar because we just walked through it. Do it anyway for practice, right? So please go ahead and work through that. Learn Git branching. This is an amazing online resource. We are only assigning some of the introductory stuff. If you want to go further, you can, and you will learn a ton. This is the website. We link to it. And it's amazing because it has a great visual interface while doing this. probably the best sort of learn how Git works website I've ever seen, which is why we love it. But we only want you to do the introductory stuff. It actually gets pretty advanced. So again, if you power through all the assignments and you want to go deeper, get as far as you can on this. The GitHub practice stuff, that is the same. And then lastly, we have a Git Essentials resource. And this we have mostly walked through. I do not think there is anything new here. So I think that one is covered by everything else. So really the GitHub practice and learn Git branching. If you have time to kill, I would go as far with Git branching as you can. If you get through all of that, or you feel like it's not a good use of your time and you want something else to do, please hit up Francisco or myself and we will give you something. Just as a general rule, there's always more than enough stuff to learn. If you ever feel like, hey, I'm ready for more, the correct next step is telling Francisco or me.